Hey, what's going on, guys? Let's do this problem right here. This question is asking to find the temperature at this junction, also the heat transfer rate. Now let's see how we can find it. So first of all, we have to realize that heat transfer rate in series. So whenever we have one single path, the Q dot is going to be equal everywhere. So Q dot right here is going to be Q dot right here, right? So how is this useful for us? If these Q dots are equal, we can equate them. We know that conduction equation is this: Q dot is equal to Ka delta T over L, right? So this is the conduction equation. Now we can equate this one for copper and aluminum because the Q dot are going to be equal in series. Now before we do that, we have to know what is going to be the junction temperature, right? So we have 100 degrees Celsius right here, and if we calculate delta TCU right here, temperature difference, and if we subtract that one from 100, that's going to give us the junction temperature. So let's note that one down. 100 minus delta TCU is going to be the junction temperature. So in order to do this one, we have to find out delta TCU first, right? Now let's create the equation. We have this copper, so first we have copper. KCU area is going to be the same, ACU times delta T. So first I take delta TCU for copper, delta T for copper, so that's going to be delta TCU and LCU, right? And in the other side we are going to have KAL times AAL times delta. So instead of, okay, let's write delta TAL first. Delta TAL over LAL. Now here we can cancel some of the things. We know that area is going to be equal for both of them because the cross-sectional area is for this bar is going to be equal everywhere, right? So this is equal for both of them. So we can cancel that. And the length of this pipe is equal for both of them because both of them have 1.2 meter. So we can cancel that one too. And we are left with this one. So KCU delta TCU and KAL delta TAL. And if I put delta TAL, we have two unknown variables because we know this KCU and KAL, we don't know delta TCU, right? And we don't know delta TAL too. But instead of writing delta TAL, we can write this one in terms of TCU. And we know that this junction temperature is going to be 100 minus delta TCU. So we can use this same expression for delta TAL. So this is going to be 100 minus delta TCU. Now let's go ahead and plug the values, right? So first we have 385 for copper, thermal conductivity, 385 delta TCU is equivalent to 205 100 minus delta TCU. Now let's simplify this one. Maybe I write in a different color. So here we have 385 delta TCU, and in the other side if we multiply 205 times 100, that's going to give us 20500 minus 205 delta TCU. 205 delta TCU, and then we had to solve for TCU, right? So let's bring them together. If you bring this one together, that's going to give you 590 delta TCU. That's equal to 20500. Now if you divide this one by 590, that's going to give you 34.75, right? This is delta TCU, but in junction it's 100 minus delta TCU, right? Delta TCU is temperature difference right here, and if you subtract that one from 100, that's going to give you temperature of this junction. Now let's calculate that one. So we know that T junction is equivalent to 100 minus 34.75, and if you calculate that one you should get 65.25, right? So this is going to be the junction temperature. Now we have to calculate Q dot. So here we can use this information to calculate Q dot. Now let's see how we can do this. So let's get rid of this part. So we are going to use the same equation, Ka delta TL. So this is going to be K is 385. So if I use for copper, this is 385 times the area, that is 0.001 meter square, times the temperature difference we calculated already, delta TCU, that is 34.75, over the length of the copper bar, that is 1.2. And if you calculate this one, that's going to give you 11.15 watts. So this Q dot is going to be equal everywhere. So this one right here for the copper, and Q dot for this AL is going to be the same thing. I hope you guys find this video helpful. See you next time.